Still talking about special right triangles today. Two special right triangles that you will see patterns in. Yes. Right over there on the shelf. Okay, let's jump right into it with your group. Everyone see the 3 triangles I provided for you. First thing, I'm telling you that they are what type of triangles in the directions? They're isosceles. There's a right angle at B, so plop your right angle symbol at B. They're isosceles. They're isosceles. What I want you and your group to do in 2 minutes right now is find AB and AC for that first triangle only. That's it. Find AB and AC for that first triangle only. Before you do that, little hint, you may want to fill in angle A. Find out what angle A is and then go from there. Okay? Find out angle A, and then I want you to find AB and AC in your groups in simplest form. Okay? Go ahead, talk it over. A lot of discussion here today. A lot of discussion. Okay, we ready? If your number comes up, anybody in your group can talk today. Okay, your number comes up, anybody in your group can talk. First thing I want to know, what is angle A? First, right off the bat, what is angle A here? 6, what is angle A? 45. Hopefully we're good to go there. 45 degrees, right? Okay, what'd you guys find was side AB's length? Side AB's length? Here we go, 13. What's the side length for AB? Also 1. Why? It's isosceles. And we know all year long we've been saying, what's across from the congruent angles? The congruent sides. And then hopefully you did something we've talked about on Friday and all year long as well to find AC. How long is AC now? Here you go, 13. AC, radical 2, boom. Everybody good. Pythagorean theorem is how they got radical 2. All right, another 2 minutes. Finish the next 2 triangles for me. Find angle A, and then talk in your group. After you finish those 2 triangles, talk in your group. Is there a pattern you see? So I don't have to keep doing Pythag all the time. Simplest radical form, simplest radical form. Sign out. Should be the pass up there. Okay, here we go. We're ready. I know all the missing angles. They're always going to be 45 angle A. I get it. 45, 45. All right. Missing sides now. Let's go missing sides for the first triangle. Here we go. 20. Let's rock and roll. What's AB? 2. And how about AC? 2 radical 2. All right. One more to establish a pattern. Third triangle. Here you go. 20 again. Here we go. AB. And how about AC? Okay. Do we have to do Pythag anymore? Okay. First thing, before we write our conclusion, what were the angle measurements in these 3 triangles? What were the 3 angles in each triangle? 45, 45, and that's what we call this first special right triangle. This is a 45, 45, 90 right triangle. Okay? They are named by their angles. And you guys found, did you guys find a pattern? Okay, I want to show that pattern in a chart now. And I'll show you what my chart means here as soon as I set it up. I want you guys to show me what the pattern is using my chart. Everyone see I got all the angle measurements on top. Underneath are going to go the sides. So let's say I knew one of the sides across from 45. I know what it is. I'm just going to put an X there right now. I know what it is. How do you find the side across from the other 45? It's the same, right? It's the same. These two sides across from the 45s are always the same. Now, as you guys did Pythagorean theorem, what was the pattern? I take the side across from the 45 and do what with it to get to the side across from 90? No Pythag. I don't want to hear Pythag anymore. I want to go quicker. All right, I want to go quicker. What do I do with this side across from the 45 to get to that side across from 90? 17, what do you do with it?
You take the side.
Which is X for me, and I do what with it? Multiply it by radical 2. There's the pattern. I take the side across from 45, and I multiply it by radical 2 to find the hypotenuse. Every time. Every time. Okay? Whatever the side across from 45 is, let's multiply it by radical 2, and I'll get that side across from 90. Everybody good there? Okay, let's apply it real quick. Here we go. Angle A is 45 degrees. You can assume this is a right triangle. BC is 18. What's AB and AC now? All right, I'm going to get you guys in the habit. I know it's very, very easy to start off with. You can do it in your head, but I'm going to get you guys in the habit. I don't know what that is. That's embarrassing, all that is. Of getting in the habit of setting up this chart, because it will not be this easy at the end of today's class or tomorrow, day 2. So I always start with, what's the rule? X across from the 45, X across from the other 45, and X times radical 2 across from the 90. What side are you given? The side across from what angle? Because I got to know where to put 18 in my chart. Okay, I got to know where. So it's across from what angle right now? 19, it's across from what angle? The 18 is across from what angle in my triangle? So I'm going to put it in my chart across in one of the 45 columns. All right, now I'm just going to use the rule. What's the side across from the other 45? Also 18. And now what do I do with my 18 to get to the side across from 90? No Pythag, don't have time for it anymore. Here you go, 1. What do I do with it? To go from the side across from 45 to the 90, I multiply it. There it is. But now at the end, please tell me though, here you go, AB is equal to what? That was the side across from 90. What did we write in our chart? 18 radical 2. And it also asked for AC, which was across from the other 45, which was 18. Questions there? I know it seems very basic. All right, I get it. It seems very basic, but what I give you from now on isn't going to be as easy. All right, next one. We're back at 45 degrees. AB is 17 radical 2. Ooh, look what I gave you now. I gave you a different side. What's BC and AC then? So does everyone see? I got a 45, 45, 90 special right triangle. So I know it's X's across from the 45s and X radical 2 across from the 90. What side did I give you? 17 radical 2 is across from 19. What angle is 17 radical 2 across from? Yep, so I'm going to put it right here in my chart. 17 radical 2. Which means, look, x radical 2, 17 radical 2. Guys, what's the value of x here? 17. Value of x is 17. Value of x is 17. So across from those other 45s are going to be 17. And I know it seems easy, and I don't want to crush your dreams right now, but here's where we're going to end of the day tomorrow. What if I just put 6 here? No radical 2 with it. What if I just put 6? And I want to find those two sides still. That's where we're going. What if that was 17 radical 3? All right? That's where we're going towards. So that's why I'm going to, I know you may hate it right now because you can do it in your head, but this is why you're writing down the charts. Any questions with the 45, 45, 90 special right triangle? Because I have to introduce you to another one now. All good with those rules? Okay, let me introduce you to a new one now. It's equilateral, that triangle. Share knowledge with me right now. It's equilateral. So, all sides are equal, okay? All sides are equal. Let's keep sharing knowledge here. Dig deeper. Yes, all the angles are, do you know what one of them would be then? Oh boy. 60, all of them are 60, yes. Okay, first theorem that you're going to need to solve these triangles down below. If a triangle is equilateral, what that means, it's the angle bisector is also an altitude. And what's an altitude do again? What's the purpose of an altitude? Vertice. Ooh, not mid. Don't say midpoint here. Perpendicularly opposite sides, so it forms a right angle. Okay, and ready? Another powerful one that you'll use, equilateral triangle. And maybe some of you could finish this for me. The angle bisector is not only an altitude, but it's also going to be a median, yep. Now, what do we know about a median? Goes to midpoints, yep. So what I want you to do, here you go. This triangle only, you and your group, simplest radical form. Find AD and BD in simplest radical form. Hey, guys, it's equilateral, and I'm telling you that BD is an angle bisector. That's why I gave you those theorems to use now. Okay, so 2 minutes. It's equilateral. BD is an angle bisector. Find the length of AD and BD in simplest radical form. Go ahead, another 2 minutes. It's equilateral, and if that's an angle bisector, it must mean it's this and this. Talk it over. Best thing you can do, talk it over. Don't hold it in. I just want those two sides. That's it. Just do that triangle only. First thing I'm going to ask somebody, first thing is the angle measurements. I'm going to ask a couple angle measurements first before I ask for the sides. Number one, are we ready? Okay, all I want to know, what's the degree measure of angle A? 60. What's the degree measure of angle ABD? 30, that's an angle bisector. And then what about BDA? Thank you. So everyone see where I got the 30 and the 60 and the 90 from? Because this is what we're going to call this special right triangle now, a 30, 60, 90. All right, side lengths now. What did you guys find? The side length of AD. The side length of AD. Here you go, 19. Side length of AD. 1, perfect. If it's a median, goes to the midpoint, cuts that side in half. Pythagorean theorem now. What about BD in simplest form? BD in simplest form, 24. Radical 3, perfect. So make sure we have those. Another 2 minutes. Do the same thing on the next 2 triangles and see if you can find a pattern. See if you can find a pattern with the next 2. Both 30, 60, 90 triangles. Okay, here we go. What are the side lengths? And then let's talk pattern. Second triangle. In the second triangle, number 8. What was the side across from, or AD, side AD? 2. And then how about side BD? All right, possible pattern. Let's just confirm it on the next one. 17. Here we go. What's AD? 3. And then how about BD? Okay. Do we see a pattern between the sides? Again, what do I call this special right triangle? It is a 30, 60, 90. I didn't use the whole triangle. I only used triangle ABD every time. So this is a 30, 60, 90 right triangle. So just like I did for the 45, 45, 90, we are going to have to chart a 30 degrees, a 60 degrees, and a 90 degrees. Okay, you guys tell me if you can figure out the rules or not. Ready? Let's say I knew the side across from 30. That's where I'm going to start. Side across from 30. Everyone ready? I know that side. What am I doing to that side across from 30 now to get to the side across from the 60? Go. Just think about it. Look at every example we've done. I know the side across from 30. 1, 2, 3. What do I do with those to get to the side across from 60? Radical 3, 2 radical 3, 3 radical 3. What am I doing? Boom. 9. What am I doing? Okay, ready? I'm going from 1 to radical 3. 2 from 2 radical 3. 3 to 3 radical 3. What am I doing to each of these sides to get here? If you add 1 to 1, you get 2. And that's radical 3. 2 plus 1 is 3, but that's 2 radical 3. What am I doing to 2 to get to 2 radical 3? I'm just that's all I want to know. I take that side and I multiply it by radical 3. We all in agreement there? Okay, a little bit tougher question now. What am I doing to these sides now to get to the sides across from 90? So 1, 2, 3, 2, 4, 6. What am I doing to that side to get to the side across from 90? 7? doubling it, multiplying it by 2. This is not going to be the easiest. That's why we reserved 2 days for it. Questions here before we really start grinding away now that we know all the rules. Okay, some of this stuff I'll do with you. Some of the stuff you're going to do on your own. Okay, can we first, I'm going to skip around. Can we first go to question 2? So flip over. We'll get back to 1 in a second. Because we just finished the 30, 60, 90, so I want to go there first. Okay, so go ahead, label your triangle. And number 2, angle A is 30. BC is 18. And we need to find what? The other 2 sides? Okay. First thing I have to do, so I can write down the correct rules. What type of special triangle is this? What are my degree measures in this one? It's 8. What are my degree measures? Okay, 30, 60, 90. Underneath, I still write the rules. So I remind myself, x across from the 30. What's across from the 60? X radical 3. And how about across from the 90? Okay, here's how we use this chart. Again, where's the 18? I need to know what angle the 18 is across from so I can put it in my chart. The 18 is across from the 30, so I put 18 there. And then I say to myself, can I fill in the rest of the chart now? Can I fill in the rest of the chart? If that's 18, x is 18, what would be the side across from 60 now? 2?
Wait, 18 radical 3.
18 radical 3. I just take x, which was 18, multiply it by radical 3. And then how do you find the side across from the 90? 14? 2 times 18. Everyone seeing how we're using the chart? 2 times 18, which would be what, Tyler? 36. Yep. The only thing I need you guys to do, the chart's not good enough. I need to actually know, hey, AB equals this, AC equals this. All right, so let's start AB. AB was across from 90. What do we write in our chart? That side was 36. AC was across from the 60. What was that in our chart? 18 radical 3. Let's skip down to number 4. Let's skip down to number 4, and I'll let you do 1 and 3 on your own. Skip down to number 4. Angle A is 30. That's a right angle. BC is radical 3. Got it. First thing, I know it's common, but what type of triangle is this? 21. What type of triangle? Special triangle? Yep, so I get my 30, 60, 90 chart with rules ready to roll. X radical 3, and 2x. Where should I put the radical 3 in my diagram? What angle is it across from? Here you go, 15. What angle is it across from? The radical 3 is across from what angle in the diagram? Was it? Is across from what angle? Yep, so that's what I'm going to put in my chart. Okay, now you got to do a little algebra. What do I do with this radical 3 to get to the side across from 60? What's the rule say? Take it and multiply it by? Okay, so ready? Radical 3 times radical 3. Oh boy, I'm not adding them. It's not 2 radical 3. I'm not adding them. You guys remember last year you multiply a radical by itself? Number underneath. Or you can do radical 9, which is square root of 9. 3. We okay there? That might be the toughest part, is the radical stuff. So that's 3. All right, how are you going to get to the side across from 90 now? Ready? What's the rule? 2 times whatever x was. Well, x was Radical 3 times 2. 2 radical 3. Just make sure you tell me what so what's AB then? AB, that was across from 90. What did we write in our chart? 2 radical 3. And AC, which was across from the 60. That was 3. There it is. Bless you. Questions from you guys? Okay, let's go to the next one here. And then if there's any time left over, you guys can go back and do 1 and 4. Or 1 and 3. Not going to like this. What if I put a 30-60 and a 45-45 in the same diagram? Well, then our head's going to explode. Yes, you're correct. Go ahead, fill in your diagram. Fill in the diagram. BCA is a right angle. BDC is. Guys, do you see a special right triangle anywhere in the diagram? Which one do you see? You see a 45, 45, 90. Everyone can see one of those. And do you also see a 30, 60? I see a 45, 45, 90, and I also see a 30, 60, 90. Everyone see both? All right, let's start with the 45, 45, 90. Name the triangle that's a 45, 45, 90 triangle. Here you go, 6. Name the triangle. Okay, so I only want to use sides from triangle BCD right now when I fill out my 45, 45, 90 chart. Only sides from that triangle are allowed. Somebody remind me, what are the rules in a 45, 45, 90 so I can start here? 22, what are my rules underneath here? X across from the 45, across from the other 45? Oh boy, see, yep. We're getting mixed. Hey, that's the big common mistake. You guys are going to get mixed up between the 45 and the 30-60. X and across from the 90? All right, let me go to somebody else. 24, where's that 10 across from? Good, it's across from the 45, so that's where it's going to go in my diagram, in my chart. Can you fill in the rest of the chart for me? Let's find out. Here you go, 9, what's across from the other 45? 10 as well. Which would be side what? What's the side across from the other 45? Name it. DC or CD. So I know DC is 10. And you can do this at the end too. I'm just trying to keep track of it right now. And what's across from the 90 then? What side length? 11. What would I put across from the 90 in my chart? 10 radical 2, which would be what in my diagram? Side, name it. BD. Okay, everyone, good so far. There's the 45, 45. We also said there was a 30, 60, 90, right? Name the triangle that's a 30, 60, 90. 13, name that triangle. What triangle is 30, 60, 90? BCA. Only are allowed side lengths from BCA. 30, 60, 90. What are my rules in a 30, 60, 90? Okay, 14. What are my rules for a 30, 60, 90? Across from 30? Across from the 60 and across from the 90? Got it. Here are the sides we already know. Okay, remember, you're only allowed to use sides from triangle BCA. What's the only side you now know from BCA? Name the side length. I already know. Here you go. 1. What side do I already know in triangle BCA? One. No. Look, triangle BCA, right? There's only one side length I know. And what angle is it across from in BCA? Okay. Everyone all right? That's 10. It's across from the 30. I know it's across from the 45. I'm done with that triangle, though. I'm down to the 30, 60, 90. Can you fill in the rest of the chart for me? Okay, 7. You're up here. What would be the side here across from the 60? Okay, and can you name that side in the diagram? That is segment what in my diagram across from the 60? The full side. AC. Thank you. Nice job. Can somebody fill in the remaining one across from 90 now? 23, what's across from the 90? 20. How'd you get it? 2 times 10. And name that side, Naomi, in my diagram. BA. Nice job. There you go. I got all of them. Okay. Questions? You and your group, go back. 1 and 3. Go back. 1 and 3. I'll write the answers up here. We don't need to pack up early. You got plenty of time. Now you're doing a 45, 45, 90. Talk it through your group. You have to do a little radical multiplication here. Remember, when you multiply a radical by itself, it's that same number. When you're trying out number 1 right now, it's that same number. I think it's safe to say we got to practice this stuff. Even though there's day 2 tomorrow, we got to practice. Good job, though, today, guys. Good job.